Welcome to today's lesson. I'm Siamasaka Krindens. I'm going to take you through a lesson today in chemistry, and basically we'll look at how to find the empirical formula. And so we'll go through the steps on how we can actually calculate the empirical formula and pay particular attention because this is very important. Normally, it requires that you follow that pattern of procedure for you to enable you to calculate the empirical formula. And so we go straight into the lesson. Actually, an empirical formula is the simplest formula for a compound, which shows actually the ratio of atoms in each element. In other words, when you have a compound and you look at the composition of atoms in each of the compound in each of that element, you will notice that actually the simplified, meaning that would be the simplest number of actual atoms in that particular compound. And so this is the procedure we are going to do. Again, the definition is actually that the empirical formula is the simplest formula for a compound, which shows the ratio between the atoms of each element. We will elaborate now, look at the procedure for actually to enable us to find the empirical formula. It's a very simplified version of how actually we can come up with the empirical formula. It is not exhaustive in any way, but I thought that if we looked at these 4 steps, they can enable us to actually remember the procedure on how to actually calculate the empirical formula. Firstly, we can find the number of moles for each item. If we are given a sample, we look at the number of moles. And secondly, we find the simplest value of all the calculated moles. So in other words, when we find the number of moles, we look at the smallest one. And then, or we identify the smallest one. And then number 3, we divide all the moles mole ratios that we find. We divide it with this, the smallest ratio of moles, the smallest moles, and therefore the last one, we compute the empirical formula using the ratio, which is given actually in step 3. And so I know this will be fully understood when we actually do the actual example. So here is a simplified version of steps that will enable us to calculate the empirical formula. I have actually made a simple equation here so that we go through the procedure for calculating the empirical formula. The question goes as follows: calculate the empirical formula of a compound with the following percentage composition: 15.8% of carbon, and then 84.2% of sulfur. So by mass, we can now calculate the number of moles for carbon by mass, meaning that we can say actually the quantity in that sample is 15.8 grams divided by the relative atomic mass of carbon, which is 12, which gives us 1.3 moles. Similarly, for sulfur, we can, since it contains actually 84.2% in the sample, so we can say it contains actually 84.2 grams divided by 32 grams per mole of actual sulfur when we look at its relative atomic mass, which gives us 2.6 moles. Okay, and so then now we have looked at the number of moles in each of these. Now we identify the moles which are actually the smallest. And we note that carbon has the smallest number of moles, which is 1.3 moles, while sulfur has 2.6 moles. So here, the second step is that we identify the smallest number of moles. So we have identified that carbon has the smallest number of moles, which is 1.3 moles. The third step is that the number of moles that we have found, we divide by the smallest number of moles. For carbon, remember, we found 1.3 moles. So we divide by 1.3 moles, which gives us 1. And then sulfur, we found that it was 2.360 moles. So we divide by 1.3 moles, which is the smallest number of moles for carbon actually, which gives us 2. And so our empirical formula will be such that carbon atoms will be only 1, sulfur atoms will be 2. And this is what we write here. So this is the simplest procedure on how to calculate the empirical formula. Now, I will include actually 3 elements in this compound so that we actually consolidate the understanding of how we can calculate the empirical formula. And so here is the equation. The compound contains 67.9% of carbon, 5.7% of hydrogen, 26.4% of nitrogen. Calculate the empirical formula. So we said the first step is that we have to calculate the number of moles. And since they have told us that 67.9% is contained in that sample or that compound, it means that we have 67.9 grams, okay, divided by 12, which is the relative atomic mass for carbon. So carbon is 12 actually moles per gram. And okay, 12 grams actually per mole, 12 grams per mole. And that gives us actually 5.6580 moles. And the number of moles in hydrogen, it will be actually 5.7 grams divided by 1 gram per mole, which gives us 5.7 moles. That is for hydrogen. The second step is that we have a third element, which is actually nitrogen, also which has 26.4 grams when we change the percentage, 2 grams divided by 14 grams per mole for the relative atomic mass of nitrogen, which gives us 1.88 moles. So the second step now, we have seen the number of moles that we have found in each of these elements, or in each of these atoms. For carbon, we found 5.658 moles. Hydrogen, we found 5.7 moles. Nitrogen, we found 1.880 moles. And so the smallest number of moles on this is actually 1.88 moles. And so this 1.88 moles is the one we're going to divide in each of these to find the mole ratio. So for carbon, we're going to divide 5.658 divided by 1.88 to gives us 3. For hydrogen to 5.7, we found here, divided by 1.88, it gives us 3. And then nitrogen, we found actually 1.88, so we can divide by 1.8, it gives us 1. And so this is the mole ratio. So the mole ratio is going to give us carbon, we're going to have 3 atoms, hydrogen, 3 atoms, and nitrogen, 1 atom. And so our empirical formula would be carbon, 3 atoms, hydrogen, 3 atoms, and nitrogen, 1 atom. And so when there is 1, we don't even include the 1 there. And so I thought this is very important to have actually the basic understanding of how to calculate the empirical formula. So next time we'll look at more complex questions on how to calculate the empirical formula. For today, I thought we'd introduce actually the concepts how we can actually calculate the empirical formula. Continue subscribing to my YouTube so that you can get more of these lessons. Thank you.